The other type of three-phase transformer connections, one is Scott connection, the other one is open delta type connection. In case of Scott connection, it mainly converts three-phase supply into two-phase supply. In three-phase supply, the angle between phases is 120 degree. Similarly, in case of two-phase supply, the angle between phases will be 90 degree. In the Scott connection arrangement, we require a special type of teaser transformer. This is the primary side, three-phase R, Y and B. This is the secondary side, part 1, secondary side, part 2. And these are the terminal volt and terminal currents, terminal voltage and terminal currents. Secondary winding, and this is also secondary winding. The total arrangement is in this manner. Mainly, we have to focus on basic. What is the basic? Scott connection mainly converts three-phase supply into two-phase supply. In three-phase supply, the angles are 120. In two-phase supply, the angles will be 90 degrees. In open delta connection, we require 3 identical single-phase transformers. All these 3 identical transformers are connected in delta manner. This is S1, S2 and S3. This single phase transformer, this is primary and this is secondary. This is primary, this is secondary. This is primary and this is secondary. In this type of arrangement, we can increase reliability and stability. So in open delta connection, even though there is failure of in one transformer, the total system will completely work and deliver the load at reduced capacity. This is the reduced capacity. So on failure of one transformer, the total load of 57.77% of the full load can be delivered, or 1/√3 times of the total load can be delivered. This is delta. Delta means when all the 3 transformers are in connection. Open delta means when one of the transformer is failed. So this is the case when one transformer is failed and other 2 transformers are in operation. Other 2 transformers are also capable to deliver the full load. For that, we have to increase the rating of the current. With the same open delta connection, if we increase the current to √3 times, then the total load, full load of delta, that means total full load of delta can be supplied with these 2 transformers. The condition is we have to increase the current to √3 times. So in delta connection, the capacity is √3 times VL IL. In open delta connection, the capacity is 57.7% of √3 VL IL, that is delta connection. Load sharing. Load sharing, if we take in terms of delta connection, load on one transformer will be 1/3 of the capacity of delta type. Load on second transformer will be same 1/3 of the capacity of delta type. The difference is phase angle. One will be 5 - 30, the other will be 5 + 30. This is for full load condition. If the load is not full load or 3/4 of the load, it can be 50% of the load, it can be 25% of the load. The load can be at any range from 0 to 1. In this case, the load on the first transformer will be load of the system by √3, and similarly load on the second transformer will be total system load divided by √3. Again, the phase angles will be 5 - 30 and 5 + 30. If the load is completely resistive load, then P can be taken as directly half of the total delta capacity. In this case, Q cannot be 0, but this Q will flow between the transformer 1 and transformer 2. So these are the two connections. One is Scott connection and is open delta connection. Scott connection mainly converts three-phase supply into two-phase supply. Angles from 120 to 90. Open delta connection. Three identical single-phase transformers are used for delivering the load. If one of the transformer fails, the total capacity will be 57% of total load can be fed by these two transformers. Mainly, open delta type connection improves reliability.